In this video, we're going to build a full football training camp from scratch, all the way into a 3D model. We'll model everything step by step, the goalposts, the stands, the seats, the railings, everything. So stick around and let's get started. Hi, I'm Hussein and welcome to my YouTube channel. In this video, we're going to model a football training camp, or you could think of it as a small football stadium, and we'll design it step by step. There are a few reasons I chose this project for today's tutorial. First, it adds some real variety to our work and gets us away from the usual repetitive project types. Second, it gives us a chance to work with several important and practical concepts at once. On one hand, we'll get hands-on with modeling structural elements and truss systems and see how to create clean, logical structures in 3D. On the other hand, we'll tackle the challenge of arranging lots of spectator seats, which is interesting not just geometrically, but also in terms of organization, repetition, and modeling efficiency. So, if you're ready to dive into a more real-world, multi-layered project, let's get started. First things first, before we start modeling, we'll set the project units to meters. As you can see in the image, I go into the options and set the measurement units to meters so that everything is in the correct scale right from the start. For this project, I already have a prepared AutoCAD file that includes a basic section and a simple plan. The plan shows the general layout of the football field and the spectator stands, while the section gives us a clear idea of the height and overall form of the project. I want to emphasize that we're using this AutoCAD file just as a base reference for our design. It doesn't fully follow architectural standards, construction rules, or detailed precision, and that's okay. At this stage, our focus is different. Practicing commands, understanding modeling logic, and getting comfortable with the workflow. Later on the channel, we'll take it step by step and dive into more precise details, structural logic, and real-world standards in future videos. For now, this level of information is more than enough for practice. Next, I'll import the AutoCAD file into Rhino, making sure all the geometry is properly transferred. Once imported, I'll organize it by placing the drawing on a dedicated AutoCAD layer within Rhino. This helps keep the project structured, making it easier to manage and work on different elements separately as I continue modeling. Then I carefully position the section exactly where it belongs in the model, making sure it aligns properly with the other elements. Once everything is in place, I lock the lines to prevent any accidental movement while we continue modeling, which helps keep the workflow organized and precise. First, I create a new layer called Structure, and inside it, I make a sublayer named Main. I activate this layer to make sure all the structural elements are placed exactly where they belong. Using the locked AutoCAD lines as a guide, I start drawing the closed curves for the stands and beams. Once the profiles are ready, I extrude them along the length of the stands. The extrusion length is controlled directly by the plan. I follow the same process for the stairs. I draw the stairs between the stands as closed curves. And extrude them about 2 meters to define their width. To make selecting and managing some of these stairs easier, I group several of them together. Then, where needed, I copy the stairs. I keep the spacing around 20 meters and make sure the placement preserves the overall symmetry of the project. In projects of this scale, keeping things organized and symmetrical is really important for readability and clarity of the space. All right, let's move on to the next step, the columns. For this part, I create a new sublayer inside structure called column, so we can model the columns in an organized and controlled way. As you can see, I use the section to mark the positions of the columns, and with the rectangle command, I draw the column profiles directly from the section. I move the profile by 20 centimeters because the column sits 20 centimeters above its foundation. Next, I extrude the column itself 50 centimeters from that profile. Now it's time for the foundation. I draw the foundation and extrude it 90 centimeters from the same level. This ensures the column is perfectly centered on its foundation and keeps everything geometrically clean and logical. Then, I group the column and its foundation so we can handle them as a single unit. Finally, I copy this module along the structure, spacing them according to the frame distances. Since we're not doing structural analysis at this stage and are just practicing modeling, I set the spacing at 10 meters. Throughout this process, I make sure the overall symmetry of the structure is preserved. Now let's move on to the roof and its truss structure. For this part, we're going to work entirely inside Rhino using basic modeling techniques. First, I use polyline to draw the truss profiles as closed curves, both the external frame and the internal members. Once the profiles are complete, I extrude them, the internal members by 5 centimeters and the external frame by 10 centimeters, keeping the structural hierarchy and readability clear. This type of modeling can also be done fully parametrically in Grasshopper. If this is your first time on the channel, it's worth knowing that we have a full Grasshopper course here that starts from zero and guides you step by step. Next, we move on to the purlins, the elements that connect the roof sheets to the truss and act like beams in practice. I draw them with polyline as closed curves and fillet the corners to get the exact final shape. Then, I copy them into their correct positions, and for now, extrude them 10 centimeters. just enough so we can easily place and copy them along the structure. In the final step, I extend them along the entire truss to form the final beam shape. You could also extrude them to full length from the beginning, and I'll explain at the end of the video why I prefer this approach. Here's an important point. In modelling, there's almost always more than one way to achieve the same form. Different methods may vary in speed, accuracy, quality, or efficiency, but ultimately, it's up to you as the modeler to decide which approach to use for each project and at each stage. Finally, we have a complete roof module. I group it and, using the column edges as a benchmark, copy the module into its exact position along the structure. I do the same process for the roof sheets, draw a closed curve and extrude it along the full length of the structure. You could also model the roof as a grid system, like we did in the tiny house video, but for this exercise, this method works perfectly fine. Alright, now let's move on to modelling the stairs. I won't repeat the layer management at every step. By now, we can assume the project layers are fully organised and structured. Using the section we prepared earlier, I set the dimensions of the stairs. The landing is 120 centimeters wide, and each step is 35 centimeters deep. After the initial extrusion, I hold Ctrl and Shift to select the edges of the steps and move them to shape each step individually. This way, I can quickly create a complete stair and then copy it, exactly like you see in the image. Once the stairs are ready, I mirror them relative to the center of the landing so they appear on both sides. Finally, I use Boolean union to combine all the stair parts into a single clean volume. Now, I copy this stair module to two other locations. I place them alternately along the corridors to create a nice spatial rhythm. Next, let's model the railings. If you want to do this directly in Rhino, the process is actually quite simple. Draw the railing lines both vertical and horizontal, and then use the pipe command to give them a circular profile. For the internal railings, I use a radius of 1 centimeter, and for the main railing, I use 2 centimeters for better readability. Finally, I copy the railing along the stairs, placing one every 3 steps. And that's one way to handle railings directly inside Rhino. But you can also do this process in Grasshopper, which is actually the method I recommend more. By creating a simple algorithm, you can model all the railings in the project parametrically. We have a full Grasshopper course on the channel that starts from 0 and guides you step by step. The playlist link is in the video description. The logic of this algorithm is simple. We take a line as input, divide it every 10 centimeters using divide curve, then draw a vertical line from each point using line SDL, and finally, bake the lines. Whenever the input line changes, all the railings update automatically. This lets you create consistent railings for different spaces really quickly. Depending on your project, you can choose either the Rhino method or the Grasshopper method. In this video, I'm using the same logic and algorithm to model the rest of the railings exactly as you see here. Alright, let's move on to the next step. Now I draw the ground, nothing complicated, just a simple surface. I model the football field the same way, but extrude it 20 centimeters. Then, I chamfer the corners slightly to soften the edges. Holding Ctrl and Shift, I select the top face of the field and use Gumball to scale it slightly, creating a gentle slope at the corners, just like you can see in the image. Before we continue, I just want to take a moment to say a huge thank you to all of you who support this channel in so many ways, whether it's likes, comments, subscriptions, super thanks, or any other way that helps keep the channel alive and active. I really appreciate it, and your feedback means a lot to me. While we're here, I also want to talk a bit about the future of the channel. I'd love for the topics we cover moving forward to be influenced as much as possible by your opinions and requests. The plan is to keep the basic tutorials on the channel, but at the same time move more toward real-world projects. That means learning through actual projects, step by step. We'll explore a wide range of examples, from famous football stadiums to iconic architectural works, skyscrapers, luxury villas, cafes, residential apartments, and more. So here's a quick favour. If there's a specific building or project you'd like us to model together, just drop its name in the comments. I'll review all the suggestions, and if I see that a significant number of you are interested in the same project, we'll definitely feature it in a future video. And if you found this video helpful so far, don't forget to like and subscribe, and I'd be really happy if you shared this video with your friends. Alright, now let's get back to our tutorial. I've actually made a separate detailed video about modeling escape stairs, and I've linked it down in the description below this video. To keep this video from getting too long and repetitive, I'll just reference that video for the escape stairs and move on here. Just to briefly mention the workflow, the stairs are modelled and then copied and placed wherever needed, exactly the same process. Now, let's move on to the next step, modelling the structural walls. Here I'll model the internal partitions and exterior walls. I start by drawing a closed curve with the polyline command and then extrude it to the wall thickness. For this project, I've set the wall thickness to 20 centimeters. I can either draw the opposite wall the same way, or, to save time, just mirror it. As you can see in the image, I repeat the same simple process for the remaining walls. For this exercise, this level of detail is more than enough. In future tutorials and projects, we'll definitely dive into more precise and detailed wall modelling. Now let's move on to the spectator seats. For this part, I'm using a pre-made bench model. All the models I use in this video will be provided as separate files, and I'll include the download link in the video description so you can practice with them yourself. Of course, if you like, you can also easily find similar models online, either for free or paid. I select the bench model, copy it, and paste it into the project file. Using Gumball, I move the bench into its correct position, placing it precisely on the edge of the first row, aligned with the edge line. To make sure it's perfectly positioned, I use the align command so the bench sits exactly where it should. Then, I place the same bench across all the seats in the first row. Here's an important tip. Before making lots of copies, turn the bench into a block. This won't change how it looks, but it will optimize your file a lot. If you skip this step, the file size can grow quickly as you add more seats. Once the benches are copied, I select every other one and move it half a bench length to create a more natural arrangement. Next, to have a path for duplication, I use duplicate edge to convert the edge of one of the stands into a curve. I select all the benches we've placed so far and group them for easier selection. Then, using array along curve, I duplicate the group along the curve. I set the spacing to 60 centimeters, which works well for this type of bench, though you can adjust it depending on the bench dimensions. After the array, I go through and manually remove any benches that fall on the stair paths, just like you see in the image. As you can see, using array along curve makes this process really quick and clean. Again, make sure to block your objects before doing large-scale copies to keep the file optimized. I model the opposite stand the exact same way, following the same steps we've done so far. You could even mirror the entire setup and adjust the length of the path if needed. But my recommendation is to go through this process yourself at least once, so you really get comfortable with the commands and workflow. Now, let's move on to the final object placement. I place objects like the football goals and benches exactly where they should be, just like you see in the image, to make the space more readable and realistic. At this stage, we can say the project is almost complete. There's just a small adjustment left. I go back to the truss beams, specifically the purlins that connect the roof to the truss. I use scale 1D to extend them along the entire structure so they act as a continuous longitudinal member. Honestly, it would have been better to do this right when we modeled these elements, but it's a good example to highlight an important point. The takeaway here is that in modelling, there isn't a single right way to do things. There's no fixed order, no specific set of commands, and no one correct method. The right approach is whatever meets your project's needs while maintaining a good level of quality. And that's it. We've modelled a football training camp from scratch, step by step, all the way to this point. And that brings us to the end of this video. In this tutorial, we explored how to model a football training camp step by step, starting from a simple base plan. Along the way, we focused on modeling logic, keeping the project organized, and using the tools correctly. In this video, I tried to go beyond just teaching commands. The goal was to share the decision-making process in modeling, how to use different methods to reach a result that's both practical and developable. If there's a specific project or building you'd like us to model in future videos, be sure to leave it in the comments. I'll review all suggestions and prioritize the ones that get the most interest. If you found this video helpful, I'd really appreciate your support with a like, comment, and subscription. You can also find the project files and related links in the video description. Thanks so much for sticking with me until the end. See you in the next video.